Good morning children and welcome back to your chemistry class. Today we shall continue to study about arenes, and over here today we shall study about how to prepare benzene, right? So the first method of preparing benzene is by cyclic polymerization of ethyne. Okay, so ethyne means we'll take 3 molecules of ethyne. 3 molecules of ethyne. When this is treated in the iron tube, right, at around 873 Kelvin, then we obtain benzene. Clear? Then the second method for preparing benzene could be by the decarboxylation of aromatic acids. So let's take an aromatic acid. For example, we take sodium benzoate, COONA, right? And this is treated with soda lime. Now soda lime means NaOH with calcium oxide, right? And it is heated. So what do we obtain over here? We obtain a benzene plus Na2CO3 is formed. Clear? Then the third method is by the reduction of phenols. Okay, so what is the formula of phenol? If you remember, this is called as phenol and it is reduced with zinc. So when we add zinc to it and it is heated, what do we obtain? We obtain a benzene plus zinc oxide will be formed. Clear? So these are the 3 different ways of preparing benzene. Now let us talk about some physical properties, okay, and then we shall come to the chemical properties. So physical properties of benzene, what do we know? It is a colorless liquid. Firstly, it is a colorless liquid and it is volatile in nature, okay. Volatile, I hope you know, which vaporizes, right? And it has volatile nature. It has characteristic smell, okay, characteristic smell it has. Then its boiling point is approximately 80.6 degrees Celsius. Its freezing point, it is 5 to 4 degrees Celsius, right? It is insoluble in water because it is an organic compound. So, insoluble in water, but it is soluble in organic compounds. But soluble in organic solvents, okay, and it is lighter than water, right? And it is also toxic and carcinogenic. It is toxic and carcinogenic in nature. About its toxicity and carcinogenic nature, we are going to study at the end. Now let us understand the chemical properties. Talking about now chemical properties. Now these benzene, they show us 2 types of reactions. They are electrophilic substitution reactions and they also show addition reactions, okay, addition reactions. So now electrophilic substitution reactions are also of different types. Like for example, we are going to study over here like halogenation, okay, then nitration, sulfonation. We are also going to talk about Friedel-Crafts reactions, like in Friedel-Crafts reaction also we have two types of reactions, okay. Friedel-Crafts reactions, they are also, as I said, of two types. They are alkylation reactions and acylation reactions. Clear? So these are the different types of reactions that we have to study. So today I am going to talk about only electrophilic reactions, and here I am going to discuss with you about halogenation, nitration and maybe sulfonation, right? Rest others we are going to discuss about Friedel-Crafts reaction and addition reactions in the next video. Okay, so let us begin with the electrophilic substitution reactions. That is the first one. Reactions. So the first reaction let us discuss about, that is halogenation reactions. Okay, so over here remember, all this electrophilic reaction, it takes place in 3 steps. So first let me write down those 3 steps, then we shall proceed with halogenation. So this electrophilic reaction, substitution reactions, it takes place in 3 steps. What are those 3 steps? The first step is the generation of electrophile. So first we have to prepare the electrophile, and electrophile is, it is written like E+, right? The second method in electrophilic substitution reaction is the formation of carbocation intermediate, right? And this formation of carbocation intermediate is also your rate limiting step. That means this is the step which decides about your electrophilic substitution reaction, okay. And the third step in this particular reaction is the removal of proton or H ion by the nucleophile. Okay, so these are the 3 important steps that we need to study about the electrophilic substitution reaction. So to begin with, let us start with the halogenation. So first part I'll write over here, halogenation. Okay, so try to understand carefully all the 3 different steps of your electrophilic substitution reaction. So my first step goes, what was that? Generation of electrophile. Okay, so let's take over here. We take a halogen, like for example Cl2. Okay, so this halogenation could also be written like Cl and Cl. Now the cleavage of Cl2 is not possible, so we take another compound, like for example in the presence of AlCl3, it can easily show the cleavage, right? And hence when we add this, we find an electrophile is formed, that is Cl+. This is our electrophile, and a nucleophile is formed, AlCl4-. This is your nucleophile and this is your electrophile. Okay, and it is also called as chloronium ion. What is it called as? It is called as chloronium ion. So this was your first step, that is generating our electrophile. Now the second step is what? Formation of carbocation intermediate, and as I said, it is a rate limiting step. So let me write down over here, formation of carbocation intermediate. Okay, so this is my second step. I hope you can understand this way. Right. So now over here, let us take benzene. Okay. So we all know that this benzene, at all the carbon atoms, we have hydrogen, isn't it? But I'm going to show it to you through a bond like this, right? And this is hydrogen over here. So this is your benzene. Now your electrophile comes over here. It is treated with the electrophile over here. So what will happen? This electron shifts towards the electrophile, right? So this electrophile, this is a slow reaction, remember. So this electrophile, it is going to attach to this benzene, to that particular carbon from where the electron has shifted. See, over here the electron shifts from here, right? So this chlorine, it is going to attach itself where? Wherever to that particular carbon from wherever the electron shifts. So it is now going to show us the structure somewhat forms is like this. Look over here first. This is your H, and because the electron shifts from here, so this electrophile comes over here, right? And let me show you this bond over here also. Now positive charge reaches here. Okay, I hope this point is understood. Now remember that it is this particular structure is no more in its aromatic character, right? Now since it is not in its aromatic character, so it is unstable now. So to become stable, to stabilize itself, now it is going to show resonance. So how it is going to show resonance? Let us look at this. So HCl will be here. Okay. So this will come over here. The electron will shift and the proton comes there. So your electron shifts here. This bond is already over here. This proton shifts where? When one electron is removed from here, the positive charge comes over here. Clear? Now this electron is going to shift. Now when this electron shifts, what are we going to observe? Let's see. This hydrogen is here, chlorine is here. This bond is already over here. Correct? The electron shifts here, so it will come over here. The double bond will come over here, but now positive charge reaches here. So this way we see the resonance taking place over here, and now it stabilizes and forms a what we say resonance hybrid, and that resonance hybrid can be shown like this. HCl, this is called as your resonance hybrid, right? I hope till here it's very clear. Now we come to the third step. We have to remove this hydrogen. We have to remove this hydrogen, that is removal of proton by the nucleophile. So let me write down over here, removal of H ion. That much I am writing over here. Now let us take the nucleophile. Now what is the nucleophile over here? This was my electrophile, this is my nucleophile, correct? So I take this resonance hybrid here. This is my resonance hybrid, and it is being attacked by a nucleophile. What was my nucleophile? AlCl4 minus, right? Now this is a fast reaction. and over here this hydrogen is removed and it forms chlorobenzene, right? And AlCl3 plus this hydrogen combines with one of the chlorine of this and forms HCl. Followed? So this is what it is called as halogenation. Over here what has happened? This nucleophile, it has accepted, this has accepted one hydrogen of yours over here. See, it has accepted the hydrogen and thus the HCl is formed and AlCl3 is aluminium chloride is also formed over here. So this was your complete mechanism, of halogenation reaction. Now we are going to talk about nitration. Second is your nitration. Okay, so let us look at this reaction over here for nitration. The benzene is treated with concentrated HNO3 in the presence of concentrated H2SO4 at 60 degrees Celsius, and here it forms nitrobenzene. Okay, NO2 plus water is formed. So now let us look at the mechanism of this particular reaction. So what is our first step in the mechanism? We will first generate the electrophile. Okay, so I'm not writing down now over here because the space is less. So first step we are doing is generation of electrophile. So let us take H2SO4 over here. It forms H ion plus HSO4 minus. Now this HNO3, that could be written like this, HNO3 with a lone pair combines with the proton over here and it is now going to give us an electrophile. So let us see the electrophile formed over here. It is NO2 plus, right? So this is our electrophile that is formed. Now our second step is formation of carbocation intermediate. So again I tell you, this is a rate limiting step. So when your electrophile, it is treated with benzene, okay, NO2 plus. So it is going to show us a slow reaction and immediately it is going to become unstable, and to become stable it is going to get into its resonance structures. So let us now look at what happens. The electron shifts from here. So this electrophile is going to attach itself where? To that particular carbon from where the electron has been removed. Okay, so let's see. This is hydrogen, this is NO2, and now what happens? A positive charge comes over here. Now this electron will shift this side. When this electron shifts, what happens? The positive charge comes over here at the NO2, the double bond comes here, positive charge comes here, para position, and this is your double bond. Now what happens? The electron is going to shift, so your positive charge will get shifted to your ortho position. So double bond is here, double bond comes here, this is H, NO2, this is plus. So these are your resonance structures where it tries to stabilize itself. And what is the resonance hybrid? What do we get over here? Let us look at the structure of the resonance hybrid. This is your HNO2 and this is your resonance hybrid. Clear? Now we move to the third step. What is the third step? Removal of the hydrogen ion or a proton by a nucleophile. So let us bring the resonance hybrid over here. It can be in any form. Okay. Resonance hybrid, I mean to say this resonance hybrid could be in any form that we see over here. So it's HNO2 and that is why I write down as a resonance hybrid. This resonance hybrid can be in any of the forms from here, right? And this is treated with a nucleophile. What was your nucleophile over there? HSO4. HSO4 minus, and this is your fast reaction, and hence what is going to happen? This hydrogen will combine with the nucleophile, it will be removed and we get a nitrobenzene over here. NO2, this is my nitrobenzene plus H2SO4 will be formed. So this was the mechanism of your nitration. I hope this is clear. Now let us now come to sulfonation. Third one is your, again I forgot. Third one is your sulfonation. Right? So let us look at the reaction first. The benzene, when treated with concentrated sulfuric acid at 330 Kelvin, it is going to give us benzene sulfonic acid. What is the formula of benzene sulfonic acid? SO3H plus H2O will be formed. Okay, this is called as your benzene sulfonic acid. Now let us look at the mechanism, right? For mechanism, the first step is what? The generation of electrophile. So let us look at the generation of electrophile. So here 2H2SO4 is going to give us SO3 plus a nucleophile, that is HSO4 and hydronium ion. Now let us look at the formation of carbocation, the second step. So we bring a benzene over here and this is treated with SO3, right? It shows a slow process. Electron is accepted from here, so your SO3 will immediately get into the so your benzene is immediately going to get into the resonance structure. Becoming unstabilized, it immediately gets into a resonance structure to stabilize itself. And where will this SO3 go to? To that carbon which from where the electron has been removed. So by this time I hope you have understood where will our SO3 move to? SO3. Okay, then bonds, let us look. Here comes the positive ion. Because one electron is removed, so the positive charge comes over here. Now let us look at the other resonance structures of it. HSO3, this is over here. Now this goes here, then the positive charge, the bond electron reaches here, so bond is formed and this becomes your positive charge. Now this electron will shift this side. So what is it going to show you next? Here and here we are going to see the double bond, and here the proton will come hydrogen and SO3. So these are your resonance structures to stabilize itself. And what are we going to see the resonance hybrid as? HSO3. Okay, this is your resonance hybrid. Now SO3 becomes minus. Now let us come to the third step, removal of your hydrogen ion from here by what? Nucleophile. So what is your nucleophile? HSO3 is your nucleophile over here. So let us bring the resonance hybrid here. Again, as I said, resonance hybrid could be of any of these resonating structures, okay? And it combines with your nucleophile. This is your fast reaction and it is going to give us SO3 minus plus H2SO4. Now this SO3 minus combines with the hydronium ion. Hydronium ion is the significance of the compound becoming acidic in nature, and therefore it forms your benzene sulfonic acid. Okay, this is your SO3H. Benzene sulfonic acid will be formed and water will be given out. So this is your benzene sulfonic acid. So this is the complete mechanism of this particular reaction that you see over here. So I hope the halogenation, nitration and your sulfonation is clear. Now tomorrow we shall talk about Friedel-Crafts reactions, that is alkylation, acylation, and we are also going to discuss about addition reactions. So thank you for today.